A look at the development from, as I said earlier, the 30s with the rigid axle all the way through to today. Starting here, as you can see, in the vintage cars, then you see a number of waves of development, innovative waves. In the 60s, the front suspension struts here, the McPherson suspension struts in the 70s and 80s with multi-link front axle combinations, and then the first air suspension here. Then as of the 2000s, you have adaptive dampers coming aboard, magnetic rider, what is called with Audi, so active chassis components. And as of 2000, you can see it's an enormously dynamic development taking place, so that lately you even had electronic components included in our big SUVs with the active roll stabilization in the Q7 and Q8, and of course the active chassis in the Audi A8. Not to be forgotten, of course, we also are talking about 40 years of quattro here, which is, of course, part and parcel when you talk about Audi chassis systems. Well, as the clip already mentioned, there's three things that is crucial for us as we set out the chassis setup and features. First of all, it needs to be clear what's the positioning of the car. Is it more sporty or is it more comfort-oriented? Accordingly, the chassis features will be adjusted and fine-tuned, and the systems and component will be selected accordingly. That must be a match. Then, the electronic architecture. We need to be able to have the information exchanged at lightning speed between the various systems. And thirdly, we've got a team of very experienced engineers working, capable of actually tuning these high-end systems to match one another, so that at the end of the day, you've got this whole composite drive experience. Let's say we get an Irishman, Norwegian, and a Danish developer and have them all work together. What would you get at the end of the day? I guess it's three different chassis setups, isn't it? No, but you want to make sure that they all fit to gel together into one philosophy. Yes, quite right. We have, of course, a philosophy how an Audi shall feel. And for that, we've really defined four attributes. One of them reads, an Audi chassis shall be effortless. It shall be solid, it shall be precise and well balanced. Well, yeah. Well, what do I mean when I say that? Effortless really means, for example, what you mentioned earlier, the quattro is, of course, a quattro drive that is so characteristic for the Audi brand. It's this effortless traction at any situation, but also effortlessly negotiating a right way around a city or on a long-haul cruise trip. Solidly means, of course, well, a comfortable car. And even if it's a comfortably arranged car, we don't want to have these secondary oscillations, secondary vibrations. If you go over, for example, well, a pothole or the likes, it shall give you this compact feel. Precision is, of course, a matter very much to do with the steer behavior, but of course also the straight light travel. And when I say well balanced, I mean, well, the basic setup of the chassis, no matter whether it's more sporty or more comfort-oriented, of course, I mean, always keeping in mind what's the objective of the car, but never having one particular position such as stand out as one single feature. So all of them, as I say, a composite whole and, a nice feel. So you need to have a certain gut feeling to work out this kind of Audi feel. But of course, with that, you also need bits and bytes, which brings me back to this little black box, the EPCD electronic platform. And I can ask another expert to join me here because he is in charge of the architecture, the network architecture, and it's Klaus Dieport. So Klaus, tell us what's contained in that ECP black box and how does it actually work? Well, the ECP coordinates, manages and controls the various chassis components and control units. But not in the classic sense. It doesn't control each one of them alone. No, it does so amalgamated in a holistic approach. The ECP was actually developed, therefore, primarily, of course, for the luxury models initially, because they have a certain complexity given the number of chassis systems on board. And so, its first deployment was in 2016 in the Q7. In its current version, you will find it in all our luxury saloons and SUVs, and will now also come into the mid-sized cars. Well, since the Q7, a number of years have passed. What are the systems that you find integrated in ECP right now? Well, depending a bit on the model, the ECP hooks up to 15 different chassis components. The working mode is that it has the sensor data coming in. They are read and processed by the ECP, including, for example, acceleration sensors, the wheel sensors, the steering angle sensors, and the likes. And then the ECP processes them, calculates certain ratios that cannot be measured. For example, here the certain angles, drift angles, and then will calculate them for the individual actuators what they need to do. That will then be sent out to the actuators as a signal, and they will then, of course, feed back to the ECP what they've done. Oh, so it sounds like a very complex integration. Carsten, is there an advantage for you in the setup of the chassis? Because if all of this is done with electronic connections, of course, it certainly does. I mean, as we said at the outset, we really want to work in real time, have all the information available about the drive status of the car. Which means we need to be able to communicate very quickly between the different components. Technically speaking, you want to have as short as possible latency times. That is possible. Just think, if this drive is just about to steer in, that information about that beginning steer ratio needs already to be from the steering transmitted to the ECP, because here we need, for example, to calculate the superposition steering of the front axle and also what's the rear axle steering angle if you have a rear steering. And to ensure this, we need simply the processing power of this ECP. Now, in the dynamic all-wheel steering, there's a lot of potential to be found, by the way, which you can also find out when you test these cars, dear colleagues out in the field. Go and pick an A7, for example, a test car A7 with a dynamic all-wheel steering on board, and you will notice that, it's quite a significant difference without and with, because you will find that turning circle is short by just over a meter, isn't it? How do you do that? Yes, you're right. The dynamic all-wheel steering is made up of the superposition steering at the front axle and the rear axle steering at the rear. Now, this small turning circle that's just mentioned is simply realized by having a 5-degree counter steer angle at the rear axle, which of course will make it particularly easy if you have to drive around a parking space or a car park. At the same time, though, at top speeds, you will have the rear steering go in the same direction as the front steering angle, which means we'll have a great stability, for example, at lane changes, and of course, a very great gain in drive stability. What's more, the driver, of course, can also tweak this. What was his preferences over the Audi Drive Select? What's his particular preference on the steering? And if you now consider all of this, you want to have this from, as I say, the tight parking space situation all the way to the fast trip on the motorway with a safe drive feel. You need a very integrated and, hooked up system like the ECP. So big sedans or big coupes become now very nimble and nifty, and big heavy SUVs with a high center of gravity become suddenly like these, cornering artists, no? Indeed, yes. Take, for example, the SQ8 or SQ7. They themselves already, with their V8 engine, have this impressive longitudinal dynamics, but this sporty character, this dynamic character, is only actually given if you combine this with the high lateral dynamics that it has. That's done by the electronic roll stabilization, which allows us not only to control the body movements, the lateral body movements, but also to distribute here these roll movements between front and rear axle in such a way that the car is superbly agile and very precise in its steer and behavior, simply to come back to the attributes that I mentioned at the start. Now, whereas Audi written on the top, you will also find precision far inside the box. But what do you do with a luxury sedan like the A8? You, the media guys, always expect the utmost in comfort, of course, customers as well. Says Carsten, well, rightly so, of course. The A8, the focus is primarily on comfort, and if we use systems here on top, then they must be able to provide this comfort. This, for example, our predictive chassis, active suspension. So here we can actually look at each individual wheel and adjust the contact patch of each wheel individually. And the ECP, using the front camera, is reading the tarmac ahead, the road profile ahead of the car. So here we can really, in certain ranges, level out any unevenness on the road trip, and thus give the passengers inside the car the feeling, they're completely uncoupled from the road, and it's a superb road comfort or ride comfort. And of course, the possibilities of ECP also allow us to look at the features and the properties that you've once developed in one car, like the SK8, and transfer them to another car. So if we have a certain system combination, as in the A8 S8, we can combine these two. So long distance comfort from the luxury class with sport-like behavior from the SQ8. Wow, you just explained the effect to us. Klaus, what's the cause for this? This is what's done with this black box. Well, I think Carsten already mentioned the important thing of latency and timing. Because if I have systems interact in this networked way, the important point is that the information happens at real time and contemporaneous to different systems. For example, the dynamic all-wheel steering. If I've got a superposition angle at the front and the rear axle angle at the rear, you want to have that happen at the same time. And this is elegantly provided by the ECP, because here all that data, all these commands are sent out at the same time. Second plus point when you look at timing is, of course, that the information exchange between the actuators, or shall we say between the different informers systems, is a lot faster. Decentralized communication between the control units happens within milliseconds. With the ECP, though, we are communicating in microseconds. Just by comparison, the lash of your eyelash, but just 1/10 of a second, and here we are actually 10,000 times faster. Wow. Impressive figures. So, Carsten, you don't let anything happen by coincidence. You want to be clear where you're positioning the car. And of course, you, the journalists, want to check whether we've done the job rightly and got it done as intended. So position an SQ8 for us, and then show us what you've done with the A8, and do so, please, in this system of coordinates here of the spiderweb. But we want to visualize, of course, the various features, and we look at well over 100 per day, and here I've just picked out 5 of the most important ones, or the key ones, that allow you to say, okay, this is the positioning of a given car. If we take an SQ8, it's a very sportily positioned car where great emphasis is put on agility, steering precision, and body control, as you can see. But for a sporty car, long-distance comfort and is of course a must, but it's not focal point here, of course, just the same as for the damping behavior, as you see here. So that is the coordinates of a sportily positioned car that you see here. But if you compare this now with a comfort geared car of an A8, for example, then it definitely is that the long-distance comfort is very, very important, just as the smooth damping behavior. Of course, given that, and if you don't have any additional systems on board, you will lose a little out when it comes to body control. Maybe you even are happy with that. And the steering precision, however, stays always here, as you see, untouched where it was. So this is how you distinguish a comfort from a sporty chassis setup. But as you just said, if you take the Audi A8 or the S8 and you have the possibility to integrate now both of these profiles and both of these functions, then well, you can simply extend this coordinate map by having all 5 of these features provided at the utmost. And it's a superb chassis, really. Well, thank you, Carsten, for that very much. Now, the question that beckons, and I'd like to ask you, Klaus, as the electronic engineer, would these two systems also work without the ECP? Well, yes, they would, because, I mean, there are very mature systems. They would work themselves, that's true. But their full potential only unfolds with the communication with one another and through their joint acting, the ECP. We always say it's like a team. You've got individual players with great talent and they talk with one another. But in some situations, you will find, well, there's a disadvantage or the advantage of the one and they can balance each other out. I mean, a good example is dynamic all-wheel steering. Here, Quattro Sports diff and rear axle steering here help you greatly for that lateral dynamics. But of course, there's situations where Quattro Sport will give the rear axle steering that little extra kick so that you really, I mean, can have the best in these lateral dynamics. But all of this only happens thanks to the ECP integration, and the systems can do so by themselves as a standalone solution. Now, I hope we've made able to explain to you a little bit why suspension is so important for us, not just with us, but maybe also for you, with the media outlets and for your next stories. Especially if you think that next, we also added efficiency to all of this. Because you may recall, a number of years when we introduced the Audi e-tron to the market, and here, as you can see, in the camouflage version, we still went up the Pikes Peak in the United States, that legendary mountain range in near Colorado. And we didn't just go up, but it also, of course, went down. A number of you were on board. And there you can see, of course, the brakes are constantly used and normally will heat up to glowing temperatures. But with us, here you can see the ranges were quite surprised, just 9 to 10 degrees Celsius. Much the same as the tarmac on which they were driving. So the energy was recuperated. Now, our expert on this is Sebastian Kirch, and he's with us now in the studio next door, together with my colleague Eckhard Kleinitz. So Ecki, over to you. Thanks, Wolfgang. That's exactly how it is. The Audi e-tron. you will recall, in our first tech talk, we already took a look at the charging infrastructure and how you charge the e-tron, and also on thermal management, which is vitally important for charging e-tron. And today, we will take a look at the third technical feature of the e-tron, namely the recuperation. That's possible thanks to the integrated brake control system. Now, Sebastian, tell us, how does that work, that system? Okay, let's start with the foundations. Normally, when you brake, you have a friction brake on the wheel, which transforms kinetic energy into heat. And that heat is dissipated to the environment and thus is really lost. I mean, that's lost kinetic energy. So recuperation means with the electric motor, we decelerate the car and we thus take the energy and feed it back into the battery. Just to give you a few facts and figures, what's happening here. Up to a deceleration of 0.3 G and up to a performance of 220 kilowatts, can we decelerate simply by means of the electric motor. And that means that covers over 90% of all deceleration sequences and processes. And we actually contribute up to 30% of the Audi range. Now, all of this is only made possible thanks to our integrated brake control system that you see here in the middle. Wow, that's a quite complex and innovative system then. Both in the setup and the development, probably everything but easy. What were the challenges in developing this system? Well, the biggest challenge really, and the biggest innovation of the system is that between the brake pedal and the friction brake on the wheel, there is no fixed hydraulic connection anymore. So we talk here of an uncoupled brake system. And the whole thing only works, or does work, by having, when you activate the brake pedal, we have this rod here that determines and reads the actual brake requirement of the driver, which is then sent forward to the brake recuperation control, and it will then distribute this torque requirement on the deceleration process to either the friction brake on the wheel and to the electric motor. Or, of course, into any kind of combination of these two, which we then call blending. And in the case of the e-tron, of course, with its two electric motors, we can even decide whether we want to, well, decelerate over both electric motors, front and rear, or only over one. Now, of course, the big question is, what's the benefit of all of this? Well, the big advantage is the driver has this one pedal feel on the brake pedal. It's a constant, uninterrupted feeling, and he doesn't actually notice which actuator is really decelerating. All of this is done automatically by the system, and he simply will always feel the same when he brakes. And the second big advantage is that our actuator here is really very fast in its calculation. For example, here, what you see here, that's the front camera of the e-tron. And if it has indicated there's an emergency brake situation, it's just 150 milliseconds until we have built up the full brake pressure here on the wheel friction base. And that is really quite fast, I can tell you. Okay, so an innovative system, which for the electric models is quite unique, isn't it, amongst its peers? So summarize once more. What's the benefit for the customer? Yes, if I conclude, you always have a good brake pedal feel, and you don't even notice the blending that happens. This is something that with other electric cars, we are quite good. The second big advantage is we can actually decide over which actuator we achieve this deceleration, whether electric motor or friction brake. And the third advantage is the entire potential which this powertrain offers us for recuperation can be utilized thanks to this system. Wonderful. Thanks for this insight. Now, as you've seen, the chassis has been extended by one third vital component, namely recuperation. But now, let's take a look into the crystal ball of the future, how we combine comfort, sportiness, and efficiency in one single drive dynamic calculator. So over to you again, Wolfgang. Indeed. And this is actually the topic for our electronic engineer, Klaus Diepold. So what can we expect of these future drive controllers? Well, it simply means we're extending the team that I mentioned earlier, that now gets a new player on board. The ECP is simply extended and amplified by the component of the powertrain and recuperation. And that means we've got the new drive dynamic central computer. So in this new control unit, we're really bundling all the functions from the drive dynamics, whether it's the classic chassis components, the lateral dynamics, or the vertical dynamics. But now on top, you also have the component of longitudinal dynamics added to this computer. Now, journalists always are looking for stories and for snappy headlines, so really facts and figures are very popular. Can you give us a few? Well, the new central drive dynamic calculator will have probably a factor of 10 more power than the current ECP, and the number of components that this new central computer will be able to handle will be about 90. Compared with this, the ECP at the moment, we're talking about 20 components that are handled by the ECP. Wow, that means these are 90 different processes and events happening at the same time in the vehicle. Can you give us a few? Well, next to the classic world of the chassis, which we, of course, we're carrying forward from the ECP, like the damper control, the air suspension, the steering systems, you now have further components added, like, for example, the transmission control, the recuperation elements, the brake control, and the entire powertrain control. So the aim is to have the entire powertrain components integrated quite independent of the powertrain version, whether it's a plug-in hybrid, whether it's an electric car, or if it's a classic combustion engine. Wow, that's really quite a bit of material, and we are now all here in the studio together. Eckhard and Sebastian have joined us, and now, well, we do look forward to your questions. As we said before, you can call in live into the show using the icon to the bottom left, the one with a hand, or just write in your questions using the chat function. And we'll start while we wait for your questions coming in, and let's warm up with our Q&A session, because each one of my experts here will get one final question to wrap it up. For him. Eckhard, if there's still a journalist say, come on, the chassis, that's no important issue for me, there's nothing new, what would you tell him? Oh, it definitely is a very gripping issue. It's quite impressive how the chassis has developed over the last 10, 20 years. I mean, in the past, you would have to, it was a matter of tossing a coin whether you want a sporty or a comfortable chassis, and today you can have this proverbial spread between comfort and sportiness all combined in one car and in one chassis setup, and that is a huge benefit for the customer. I mean, quite practically speaking, look at the dynamic all-wheel steering. That offers you, on the one hand, superb comfort, superb agility and nimbleness, but at the same time also gives it that great drive dynamics at a sporty ride. And this is what the customer can experience, and it is the interplay between the hardware and the software that you see here. And that is, I think that is really the beauty of the new chassis developments. So, Klaus, to you, more electronics in a car, does that mean it's a better car? Is that equals a better car? Well, the advantage of the ECP is, of course, I mean, from the chassis perspective, is quite simply extrapolated to the new dynamics of drive dynamic computer. Timing and latency, of course, are greatly improved between the systems. All of this happens at a much greater speed, which I cannot realize with the decentralized character of the various control units. And of course, the longitudinal dynamics have, of course, a bearing on the chassis. Just when you brake or when you accelerate, I mean, through pitching and the likes, you will note this. So it brings together what really should have always been together, and the advantages will be tangible for the customers. But Carsten, I mean, all the same, every unit, every component should work by itself without all that electronic aids. Right, you're quite right with that. I mean, the basic chassis components of which we're still on, the basic chassis setups that we're still selling in large numbers without these control systems, need to be a perfect match. I mean, every Audi chassis without these control units, with steel spring and conventional chassis systems, needs to be very good and befitting the attributes I've mentioned. But of course, the control systems can improve them. We can actually, we can break up the compromises that we sometimes make, and the spread can be increased. And if you combine the systems, you of course extend the possibilities. All we need to do, we have to make sure that the drive feeling is not system specific and you just pick out one given system, but as I said, always this composite whole, like the way you were to drive the car without these control systems on board. That's quite comforting to hear. Thanks for that. Now, Sebastian, to you, you showed us a completely new braking world from the e-tron. And here, well, you can see that the chassis and the powertrain are working together to save energy. But what happens if I have no electric SUV? What benefit is it for me? Well, look, recuperation is always dependent to what extent your powertrain is electrified. So, I mean, a pure electric vehicle is, of course, ideal. Yes, by all means. But we're taking this one further because a plug-in hybrid or a mild hybrid also offers these possibilities now. The other advantages that this brake system offers us are quite independent of the powertrain version and can be applied, and can be used with all kind of transmission and powertrain types. thanks for joining us. We will be happy to have you with us next time. We really appreciate it that you've taken time, because of course lately it was difficult due to the corona pandemic to meet up, and of course there's no trade shows, there's no events, no dynamic presentations. So we thought, hey, why don't we just meet up in the virtual marketplace here? So we'll be back soon with other exciting topics. So thanks on behalf of the experts from the Audio Communication, and well, we'll see each other soon, and stay healthy. Goodbye.